The electromagnetic spectrum refers to the wide range of radiation that comes from stars like the sun. Radiation travels in waves. The length of these waves varies from as large as a football field to as small as a single atom. The visible light waves exist on the pretty darn small area of the spectrum. There are 4 different factors that help us see what color something is. First, there's the light source. Second, there's the actual object that we're looking at. Third is our retinas, the cones and the rods that are on the back of our eye. And fourth is our brain, our processing power. The light source is really important when it comes to how we see color. If the light source is shining pure white light, then we'll be able to see all the colors. If the light source has a filter over it, like a red filter say, then we'll only be able to see red light because the red light waves are the only ones that are going to be able to get through the filter. So remember, a color can only be reflected and seen if it's being emitted from the light source. If the light source is not sending out pure white light, then the colors that we see are going to be skewed. Second is the object that we're looking at.
So, what if you had a yellow pencil sitting on your desk? Well, the sun emits all colors of light, so light of all colors is hitting your pencil. The pencil looks yellow because it reflects yellow light more than it reflects the other colors. What happens to the blue, purple, and red light? They get absorbed, and the energy they're carrying gets turned into heat. It's similar with objects of other colors. Blue things reflect blue light, red things reflect red light, and so on. White objects reflect all colors of light, while black things do exactly the opposite and absorb at all frequencies. This, by the way, is why it's uncomfortable to wear your favorite Metallica t-shirt on a sunny day.
Again, third is our retinas and the cones and the rods in our eyes.
Now we see colors because of rods and cones in our eyes. And we've got 3 types of cone cells for seeing red, green, and blue. A lot of other mammals only have 2 kinds for seeing blue and yellow. Birds have 4 and can see all 3 of those colors and ultraviolet light, which is one of the reasons that birds are so creepy.
And the 4th and final factor that affects how we see color is our brain. You may or may not know this, but our brains can be trained and tricked.
Okay, so we're going to create the color after image in your brain. What you need to do at this point is to stare at the dot in the center of the photo and keep staring at the dot. Don't move your eyes, keep staring at the dot. The photo is strangely colored, that's all to do with the demo, so just keep staring at the dot. And in about 20 seconds time or so, the photo is going to be replaced by a black and white version, but you're going to probably see some color in that photo. So keep staring at the dot. That's good. Don't move. Keep staring. There we go. If you move your eyes quickly off to the side and then back to the dot, you should see the black and white photo, and then the color should reappear when you get back to the black dot. Probably starting to fade now. You're all probably familiar with the idea that a TV screen makes colours using red, green and blue pixels at each point. Each colour we see is a particular mixture of these colours. Our eyes aren't TV screens of course, but they do contain 3 types of colour sensitive receptors known as cones. One sensitive to red wavelengths of light, one green and one blue. So the way the brain sees different colours is by looking at the relative activity across 3 types of cones. So, when you stared at the strangely coloured building, you were in fact tiring out or fatiguing the 3 types of cones in different ways across the photo. The area of grass was painted mauve, for instance, and this fatigued the red and blue cones that have a view of the grass more than the green cones. When we now replace the strange photo with a black and white photo, we are in fact seeing colour created by different levels of fatigue in each of the cones. The brain only knows about different colours by looking at relative activity across the 3 types of cone. Remember I said if you moved your eyes when looking at the black and white photo, the colour after image disappears? Well, this is interesting because this tells us that the structure of the scene you use to see the after image must be similar to the structure of the scene you use to tire the cones out with. Any old building won't do. And the same building placed in different positions on the retina won't do either. This may explain why we don't see colour after images all the time, because our eyes are continually moving around.